Welcome back, team, and welcome to AWS and Linux Foundation course. Right, we are discussing how to use our AWS EC2 instance and configuring a web server over there and accessing the web application from the public internet space. Right. So yes, I have the EC2 instance that is created in our AWS account, and I logged in here. Right. So we all know that we can just use yum install command to install our the Apache HTTP web server application, right? And we can start the services using systemctl start httpd. We can go to where www html location, right? This is where we need to deploy our code. Whatever the code that we deploy here, that is accessible as a web application. So far so good. We have seen the DNS mapping as well, how the web application will be accessible using the actual domain, right? So today the agenda is to discuss about the Linux file systems. Okay, so we'll talk about Linux file systems, the mount and unmount processes, inode concept, and we'll also talk about the AWS level EBS volume management. There are a couple of things that we are uh, discussing today in one single session, guys, to make it a complete real time, right? Well, so first let's get into the problem that we have at this time, right? When we are keeping some data in my Linux operating system, right? Some data is related to the operating system configuration. Some data is related to your website or web application, correct? So as an example, let's say I'm just calling out /etc/passd/psswd file. Yes, this is also a file that is holding of some data, right? But is this the data related to the business? The data related to your application? No, correct. So there are a lot of, let's say, the USR. Under the USR, whatever the data that you see, all this data is actually related to the operating system, right? If your operating system has to be up and running, then definitely some data that it has to use, right, in order to run the services, run the scripts, configuration data, configuration file. Agree with me? So I'm just splitting my data it into two categories. One is the operating system related data. One is the custom specific user data, like a application or a client specific data, correct? So I don't want I don't want to keep the customer data, which is your website data, and the operating system data it into the a single hard drive. I'm sure you guys are aware of that. Whatever the data that we are keeping in your Linux machine is actually storing it into the hard drive only, right? Think of like in a Windows machine, right? Usually the Windows itself is having or providing you the multiple drives like this, right? I think I'm sure you know that the operating system data will be in the C drive, and any specific data that you wanted to store will be in any other drives, right? We are not mixing the whole data into the C drive itself. We are following that best practice, right? So why we should not mix our custom specific business specific client data it into the same drive where the operating system data is also there, right? That is not a good practice. Let me follow the same practice here as well, guys, right? So the data that I'm going to keep in my var www html, so can I say this is definitely a customer specific data, maybe a website code, maybe a website images, maybe the videos or whatever you are actually utilizing as part of your web application, all that is related to the business specific. I don't want this business specific data and your OS data is into a single hard drive. That's what is the goal. What do we do now? So rather I'm going to say, let me go and create a one more new volume. On the new volume, I'm going to store my new uh, website related data, guys, correct? Volume is the terminology that I'm using here in terms of the AWS infrastructure. Volume is mean that the hard drive that I'm going to attach to this, correct? So lsblk is the command to see the list of block devices. The hard drives or the volumes that are currently attached to this EC2 instance is called as a block devices, because the data will be get stored in these volumes in a block by block, right? And as of now I can see there is only one hard drive is attached. You see this, the type is disk. Wherever you see the type is disk, that is the hard disk that is currently attached to this server, guys. Usually by default there will be only one hard disk that will be attaching to your EC2 instances, that will be used to store the operating system related data. You can see that 8 GB of hard drive is currently attached. The every hard drive will be having the name as well. You can see XVDA is the default name that is given to your hard drive. Think of like how you are getting C colon as the partition name at a Windows level you guys are using. Same thing like the hard drives that are attached to the Linux machines here is labeled named as XVDA, right? And this is the disk. As of now, any file that you are creating, any directory that you are creating, everything is actually saving in this drive only. But as I said, I don't want the operating system data and the custom business specific data storing it into one single volume. That's the reason now I need to attach here one more new volume. On that volume I would like to store my business specific data. That is the requirement. If I need to get a one more new hard disk attaching to my server, to whom I need to ask? This is the AWS EC2 instance, and AWS is the infrastructure provider, right? I need to go to the AWS to start creating the volume, guys. Volume is the AWS specific terminology. All what I need to do is go to the AWS management console. In the left side navigation in your EC2 service, you can see the volume tab. The volumes that are supplied by the AWS are called as elastic block store volumes, in shortcut EBS volumes, right? The EBS volumes are the one which I can create and associate to your EC2 instances in order to start storing the data over there. Good. So you can go to this volume tab, then you can start creating the volume of the required size in order to store your custom data in the new volume. Good. So the basic rule here is, okay, the volume that you are going to create must be specified into the specific data center, which are called as availability zones in the AWS. Okay. So here in the US, sorry, it is in Mumbai region, right? AP South 1 is the region code, right? In this region, there are multiple zones are available within the AWS. Each zone is like a data center, right? So the volume and the EC2 server both must be created in the same availability zone in order to start using that volume to store the data. What I do now, first I will go to my EC2 server. Okay. First, I'll go to my EC2 server. I will verify my server is currently running in which zone. I can see that AP South 1A is the zone ID that is corresponding to my server. Then you go back to the volume tab. Then you start creating a volume. Once you click on the create volume, you get this form to be filled up, right? The EBS volume can be created in different types that you can see here. The type that you choose here will differs in terms of the pricing, the performance, the maximum file, the maximum volume that you can create, the size of the volume. All those are the different behaviors or the differences between these different volume types, guys. Whichever the volume that you like it, you can pick the one. General purpose SSD GP2 is the default type. You see, If I go for GP2 volume type, right, I'm getting like a minimum 1 GB hard drive that you can create, maximum 1.5 GB volume that you can create. Let's say if you go for the other type of the volume, you see the minimum is 4 GB. This is how some differences between the one volume type to other volume type, whichever you feel comfortable based on the requirement, we need to choose the volume type. The performance also will be vary from one to the other because the backend technology will be changing, right? You see, these are the SSD type of technology, and you can see the magnetic type technology, HDD, which is the olden days of technology to create a hard drives. So because the technology changes between the type to the type, definitely the performance also will be vary, right? And also the pricing. So whichever you feel comfortable, you can pick the one and specify the size of the volume that you are looking for. Let's say I would require a 5 GB of volume, 5 GB of hard disk, right? And you have to specify the volume has to be created it in the which zone, in which zones the server was deployed, the volume must be created in the same zone only. So select the zone here. In my case, the server is created in 1 year zone, hence my volume also in 1 year zone. Fill up these minimal details and click on create a volume. Once the volume is created here, the volume ID is assigned. You can see 5 GB is the size. AWS will be reserving 5 GB capacity, storage capacity to you. And this volume you need to attach to your EC2 server. Select the volume, go to Actions, attach a volume. Now you select the server from the drop down to which server you are expecting this volume to be attached. And you see this is the naming convention of a new device. The volume that I am giving to this server, right, it is having this naming standards, right? You see here the recommended device names for a volumes. It will be like slash dev slash sd f2p. These are the different names that are recommended to be configured. AWS is automatically configuring one name, but if you want to change this name, you can change the name based on these guidelines, guys. Not a problem, right? This is the name that you need to use at your operating system level to start using this volume to start keeping the data. Let it be the default name, whatever the AWS is suggested for this volume. Just click on attach a volume. Once the volume is attached to your EC2 server, you just go back to your Linux server, which is the EC2, and run lsblk one more time. This time you see there is a one more new volume of 5 GB size. The type is disk, and you can see the volume name, which is xvdf, right? So whatever the volume name that you see here, that is the volume name that you need to use in order to start keeping the data in this particular 5 GB of the disk. That is how we can add multiple hard disks to your EC2 server, guys. Technically, from AWS language perspective, we can create and attach multiple volumes to your EC2 server and can start keeping the data in these volumes. Now, because I have two volumes, correct? One volume is XVDA of 8 GB, another volume is XVDF of 5 GB in size. Now I can choose that operating system related data, I can keep it in the XVDA. Any custom business specific, the data that I am creating for my business purpose, maybe a website related data, that I can keep it in the XVDF drive. That's how I can split my data, right? At least the custom data to be in my specific hard drive, guys, or a volume. Cool. That is the story behind why should I be creating a additional EBS volume and attaching to the server and how to do that. Once the volume is attached to the EC2 server, this volume I cannot use as it is to start storing the data. When I say what does it mean by storing the data? It's all about creating a file and keeping the file data in the volume. That is what does it mean by storing the data in the drive, right? So you cannot use this drive as it is, because by default the drives are drive in the sense the volumes are in the raw format. Raw format in the sense these drives are not in the acceptable format, right? Not in the structured format to start storing the data, whatever the files that you are creating. That is where we need to understand how should I be, start using these raw volumes in order to start pushing the data to that particular volume. That is where we need to understand the Linux file system concept. You see here, I have attached a volume to my Linux server, which is the hard drive, right? So this is in a raw format, in the sense that there is no structure formatted in order to be compatible to store the data. There is some name is given for this volume, let it be, and there is some size. All what we need to do is the volume has to be divided it into the number of blocks in order to make this as a compatible to start storing the data, guys. When you make this volume it into the number of blocks, right? So the each block is dedicated with some size. If the volume is 100 GB, each block will be having like 4 KB or 64 KB or 128 KB, based on the block size that you prefer, right? The whole volume will be get divided it into the number of blocks. Why so? If the volume space is divided it into the number of blocks, it's very easy to start storing the data into these blocks by addressing the block numbers. This is like, I used to give this example. If you have a very big floor and you wanted to arrange the things, it's very difficult to arrange the things if it is having a common floor. Rather, if the floor space is divided it into the number of blocks, partitions, tables, it's very easy to organize your data kept into the different places and identifying the data as well, right? Same example. So if you are having a 100 GB of volume as an example here, it's very difficult to start storing the files here. These are smaller files. If it is divided it into the number of blocks, we can store the data it into the block numbers, and we know exactly which file is stored it into the which block. That's very comfortable way, structured way in order to start storing the data. Dividing your volume it into number of blocks is called as a file system, because the file system is the terminology that I use here. Is mean that preparing your raw volume into a structured model by dividing that space it into the number of blocks and preparing a organized structure and keeping the number of blocks over there. Then you can start storing the data. Right? Once the number of blocks are divided, once this volume is created as like a file system structure model, then in order to store the data, right, as you know, how are you guys will be storing the data in the Linux systems? Forget about this volume concept. Ideally, you guys can store the data into a directories, right? I mean to say, keep the content in a file, keep the file in a directory. The directory will be part of any other parent directory. That is the usual Linux file and the directory structure, right? So far we know that we can keep the content in a file, the file will be in a directory. Without me worrying about how this volumes works, hard drive works, so far we were able to create a file and directories. Somehow the file and directory is actually storing into the volume only, right? Ultimately. Without a volume, without a hard drive, how come you can create a files these days? Correct? But in the backend, yes, the volume is there to store the data, but in the front end side, from the user perspective, you always be using the directory to start storing the data, right? So that means you pick up any one of the directory where you wanted to store the data. That directory has to be associated to this particular volume. From technical terminology perspective, this directory has to be mounted on this volume to start storing the data, guys. It could be any directory that you like, it can take it and can start mounting it into this volume to start storing the data. Once you pick up a directory and you mount it in the specific volume, then onwards any file and directory that you are creating under this as a parent, all those are storing into this particular volume only. That is how the concept works. Just to repeat some of the statements, once your raw volume is formatted and created as a structure, this volume is called as a file system. The corresponding directory which is attached to this formatted drive, that directory is called as a mount point. Sometimes we can even call this directory as a file system as well, because that is addressing as a entry point to start accessing your volume to start storing the data. Let's make this implemented, guys. Okay, so if I go back to my Linux system here, now I can see that I have got a volume of 5 GB in size. Now my goal is to start storing the data in this volume. Step number one, because the volume is in raw format by default without having a structure, it will not be compatible for me to start creating the data, right? The first thing that you need to do is format. mkfs is the command to create a file system. Creating a file system is mean that dividing your raw volume it into the number of blocks and creating a structure is called as a file system, right? So mkfs, make a file system, specify your volume name. xvdf is the volume name, and always, as you know, right, any file or anything that is in the Linux will be having a absolute path, correct? So xvdf is just a shortcut name, but the complete path of this volume is in the /dev location. Like so far we were discussing about /usr to keep the binary files, var to keep the log files, right? And home is to keep the home directories. Same way, /dev is the default directory that is holding of the devices information. Here the storage device, right? The block device or a volume, right? This volume absolute path is under the dev location only. Hence the reason you have to use any volume by having /dev as a prefix, which is the complete absolute path where this device is located, right? As a file format, right? That is the reason when you are running the mkfs command, you have to specify the absolute path and the volume name. When you are doing the format in the sense making this volume it into the number of blocks and preparing a structure, right, to store the data. The format can be done in multiple types. The types are ext2 is the one of the type, ext3 is the other type, ext4 is the another type, and xfs is the another type. These are the different types of the format, guys. Okay, whichever the format type that you use, at end of the day your volume is will be divided it into the number of blocks and it will be ready as a file system to store the data. But this format types will make some differences in terms of how it is actually creating it into the number of blocks. That's only the difference. Rest everything is as usual. It's up to you which format that you would like to use while you are formatting this particular volume. Let me use ext4, the format type, and you hit enter. You see the output is referencing that, right? It is using 4096 KB, which is, sorry, bytes, which is like 4 KB. 4 KB is the block size, which is the default block size. Each block is divided with the 4 KB size. You see the total this many number of blocks are created. You see here, these are the maximum Yeah, these are the maximum number of blocks that are created, and the blocks are actually grouped it into the block groups. You see, there are total 40 block groups are created. That means, so your 5 GB capacity of the volume is divided it into the total number of blocks, right? Yeah, this is the number, total number of blocks, right? These blocks again divided it into the groups. There are 40 block groups are created, right? And you can see somewhere that it is actually creating a super block as well. So somewhere it will show you the information. You see, super block concept is created. So at a high level, I would say that whenever you are running this mkfs command, this is actually creating a structure in your volume. When I say structure, is mean that your space is divided it into the number of blocks. Each block is having 4 KB in size. The blocks are labeled with a number: block 1, block 2, block 3, so on so on. There are some block groups. Some super block is created to maintain this, the total characteristics of this file system structure. So this is whole the structure. Once your volume is ready with this structure, then your volume is ready to start accepting the data to store it, guys. Good. Maybe once you get a volume to your EC2 server, how will you know that this volume is currently a raw volume or this is already formatted as a file system, correct? You can use a command called file-s just to verify that this particular volume is currently a raw volume or it is already formatted as a file system. If this is already formatted as a file system, you will be getting this kind of information. You see, this particular volume is currently formatted as ext4 type of the file system and some more information, guys. This is confirming that yes, this is now a not a raw volume. This is already formatted as a file system structure. This is ready to start storing the data. Step number 1 is completed. The step number 2 is now you need to choose a directory. Which directory you would like to attach to this volume in order to start storing the data. Why? As a basic Linux architecture, you cannot store a file into the volumes directly. Always the files can be created in a directory only, not into the volumes directly, right? So you need to choose any directory, guys. Let's say I'm creating one directory, whichever the directory that I would like to use to store my data. Then you need to mount this particular directory into a volume, right? So I'm running the command. You see this command is says that slash data is the directory that has to be mounted on this volume. When I say mounted terminology is mean that this directory is acting as like a access point, entry point to access this particular volume data. Once you do the mount command, then you can go inside the slash data directory. So if you are inside a slash data directory is mean that you are currently inside a volume, guys. That's how you need to understand, because from now onwards anything that is related to the volume can be accessible through a directory called slash data. So I would say that slash data directory and xvdf drive both are same at this time. I'm just accessing this xvdf volume with the help of a directory as the access point. So if I'm inside a slash data directory is mean that I'm inside a xvdf drive. If I create a file inside the slash data directory is mean that this file is currently storing in the corresponding associated volume, guys. Make sense? I'm done. So I am able to create a file system and mount the file system into a specific directory as a mount point. And when you start creating a file and keep the data in the file, that data will be actually storing in the XPDF volume only. df-h is the command to see more details about your file system. It will show you the specific entry here stating that XVDF is the volume which is having 4.8 GB of total size. It won't show 5 GB because some space will be used internally. So 4.8 is the usable space that you have for storing your data. It will tell you like how much data is currently used, how much is free space left in the volume in terms of the percentage, and it will tell you which directory is currently mounted on this volume. Right? This is just giving you the details about the file system utilization pattern just to understand out of the 5 GB volume how much data currently and how much space is left over to start keeping the data. That means in the slash data directory I can keep 4.6 GB of the data that will go it into this particular drive, guys. That's how it works. Let me clear the screen. As I said, if you go inside the slash data directory, is mean that you are currently inside a volume. The slash data is just a access door to access your space volume. At any given point of the time, let's say you don't want to use this volume data, right? The way how you have mounted this, you can even use the unmount command, umount command to unmount this directory. But again, when you are unmounting it, you should ensure that you are not inside a directory, guys, because if you are inside a directory is mean that you are inside a volume. If you are inside a volume, you cannot unmount it. Unmount in the sense the directory has to be deassociated to your specific volume, right? If that is the case, it will throw you that hey, the target is busy. That means your volume is currently in use because currently you are inside the volume only and it is not possible to unmount it. You can use the fuser command just to see who is currently using this particular slash data file system. You see, it's telling that root user is currently logged in and using this particular slash data file system. That's how you get the information, guys, just to understand who is currently using this particular file system if it is throwing the error that the file system is currently in use. Yes, and we can use the command called fuser-k as well just to kill the process, or else, as you know, right, this is the process ID which process is currently using this file system. You can even kill this process ID as well so that the process will be get killed in, right? And of course sometimes it may kill, sometimes we need to use a force flag, but it's not recommended to kill the processes. Just identify the owner user and inform to this guy that hey, you are currently using this file system and please don't use this file system because I need to unmount it. That's the process. You see, I'm coming out from that slash data folder. Now if you run umount command, it will definitely works because no one is using this slash data. The df command will show only the volumes that are in mounted state. You see, sometime back the df was showing the xvdf. Now the xvdf is not showing here. So only if it is mounted and accessible, then only the df will show you the characteristics, or else no. Sometime back in the slash data directory, I kept a file called f1, right? Can I see that file now inside the slash data? No. Why? At this time, slash data directory is not mounted on the xvdf drive, right? When it is not mounted on the xvdf drive, then it is not referring through, it is not accessing the data of xvdf drive. So obviously sometime back the data that you created in the slash data directory, that is actually created in the XVDF volume only. The slash data is just a access point, a entry door. The entry door can be changing, not a problem. Again, take an example. You have a house. You kept some data inside a house. You put your entry door, right? Through the entry door, you go inside a house to access the data. Tomorrow you change the door. If you change the door, do you think your data will be changing? No. Through a different door that you have changed, you can still access the same data. So ultimately, right, it is important that your data stored it into a which volume, not the access entry point. Next time when I'm trying to access the data, I can mount my XVDF volume into a different directory, not a problem. You see, this time I'm mounting it into the different directory called var www.html. Even this is also a directory, right? You can choose any directory that you would like to mount it on a volume. Now, what will be the data inside the var www.html, guys? You see, the F1 file that was created in the slash data directory sometime back, the same F1 file now accessible inside a var www, because whichever the directory that you use to mount, that is just a entry point. It is actually fetching the data from the corresponding volume. Cool, right? So I'm just proving that the directory that you are using here is just a entry point, that is not a permanent path to store the data, guys. Right, the data that you store in the directory, that is going to the volume level, and the volume is actually holding off your data. I'm just proving that. Now let's say I'll just come out from that location. You see, now maybe I'll show you the df command. This time the df command is saying that this volume is currently mounted on this volume. Anything that you see in this volume, in this directory, that is getting the data from this volume only. That's how these directories are acting as like a mount point, access doors to access the data. You unmount it. Now can you see the data in the var www.html? No, because sometime back it was showing the data because that was attached to the volume, and it is getting the data from the volume. When you do the unmount, this directory is not referencing to your specific volume, guys. So the final statement is, right, the volume is mounted on which directory, that directory will start referencing to that particular volume. Any data that you keep it there, it will be going and storing in that volume only. And whenever you wanted to use the volume, you mount it. Whenever you don't want to, you can unmount it. Only the mounted file systems can be accessible, can store the data into the volume. Unmounted one cannot use. You see, now I have unmounted this volume. Now if I want to store a data in the volume, I can't, until unless I mount it into any one of the directory, and through the directory only I need to start storing the data. Good. That's how the file system concept works, and that's how we need to mount it. Ideally, now there's a three-step process, right? Once you get a volume, the very first command that you need to do is run a mkfs command to make this as a blocks or a structure, right? The second step, you mount a file system. I mean to say, take a directory and mount it into the directory and start pushing the data to that directory. So good. Maybe for our specific purpose, I can do this, right? Let's say mount slash dev slash xvdf slash var www.html. Now you go to var www.html. In this location, you start putting your website code, data, or whatever. So is that achieve? Am I achieving my goal? My goal is the custom business specific data, I don't want to be keeping in the same volume where my operating system is also storing my data, correct? Now you see, any data that you see in this var www html, the code, data, images, videos of your website, those are getting stored in the xvdf drive. Any other operating system data is actually storing it into the xvda. That's how I'm segregating my data, not to keep it in a single volume, guys. Sometimes, as of now, I have used this volume as it is to store my data it into one single mount point or a file system. It is even possible, let's say, take the other scenario. You take one volume, let's say 200 GB, one volume is there, right? A single volume can be divided it into multiple partitions as well, guys. Sometime back I have shown you the whole volume can be created as a file system mounted into one single file system. But now I'm showing you the second approach. It's even possible to divide the volume it into the partitions, and each partition will now start working as like a separate independent volume. Each partition can be created as a file system and can mount it into the different directories as well as like a different file systems. You see here the 200 GB volume, I made it into two partitions. Ideally, if the volume name is SDC as an example, the partitions names will be SDC1, SDC2. That's how the naming standards guys. And each volume can be created as a file system, can start storing the data. Why do so? Why should I do this? Let's say I have a bigger volume. I have 200 GB volume is there, but I have some two different business related application data. I don't want to keep all of them it into one single volume. I wanted to separate them it into different volume model, but I have a bigger volume, right? So you can make that as a partitions and use the partition as a disk and start storing the data on that specific partitions, guys. Right? The whole total size of the partition should definitely be equal to your volume size only, because the same 200 GB I'm just making it into the number of partitions to just for our flexibility to maintain a different file system to store the different category of the data. Good. When you are creating a partition, so you can create multiple partitions, not a problem. The rule says a single volume can be divided it into maximum of 4 partitions only. These are called as a primary partitions. There will be only 4 primary partitions can be created. Let's say a single volume has to be divided it into multiple partitions, more than 4. Then you create 4 as a primary partitions, and a one of the primary partition can be divided it into multiple partitions, which are called as a extended partitions. That is feasible. From the volume directly I cannot create more than 5. It will be like 4 only, right? Within the 4 you can take one as an extended partition to create any more, guys. That's how possible. But again, when it comes to the real-time perspective, why should I be worried about dividing my 200 GB volume it into multiple? Rather, if my requirement is I need a 50 GB file system, why can't I go to the AWS and create a 50 GB volume? If I need a 150 GB volume, you get it 150 GB volume from AWS only, right? But this is the concept which will be applicable if in case you have a bigger volume with you and you don't want to use that volume as it is, you wanted to make it into partitions, then only this concept will be a meaningful. Or else, why don't you take a lesser size of the volume and use it directly, right? Correct. So now When you are making it into the partitions and the whole volume cannot use as a file system, only the primary partition can be partitioned. If you are making it into the extended partitions, only the extended partitions can be created as a file system, can start right mounting it as well, guys. I'll show you what does it mean here. Let me unmount this because currently the volume I have used as it is, right, as like one single file system, right? Now let me show you how to divide this it into the partitions and use each partition as a separate file system. Fdisk is the command to divide a volume it into the partitions. The fdisk will take you this type of the interface, the prompting based interface, right? You need to run m command to take the help. These are the different commands that are available here in order to create a partitions. Out of that, you see n is the command to create a new partition, right? And somewhere you can see w is the command to save the partition information. Let me follow these commands, guys. N, you see now it is asking you would like to create a primary partition or a extended partition. The primary partition can have maximum of 4 only. So you specify that, hey, I wanted to go with the primary partition. Then it is asking you the primary partition number. It could be 1, 2, 3, 4 only, right? Because only 4 partitions can be created. This is the first partition. Let me take the partition number as 1. Now it is started selecting the size of the partition, right? Internally, your whole 5 GB volume is divided it into the number of sectors. So it is started showing you the sectors here. We don't need to worry about that. You just worry about the last sector. That's where we need to specify the size. Let's say this is the total 5 GB volume, right? Maybe I would like to take 2 GB as one partition. Just specify the size of the partition that you would like to. Then you use W command to save it. Now you see fdisk-l/dev/xvdf. The xvdf drive is actually partitioned, and you see the name of the partition, which is xvdf1. Like that, we can create multiple partitions, guys. Of course, 4 primary partitions. You see, fdisk/dev/xvdf, n for new partition, p for primary partition, 2 is the primary partition number. The starting selector sector can be a default. Ending like I need another 2 GB size. Save it and come out. Right? fdisk-l/dev/xvdf. You see, now your volume is divided it into 2 partitions. Each partition is of 2 GB in size. Now you can create like a slash, maybe slash app, right? You can do mkfs-t ext4/dev/xvdf1. The first partition I am making it as a file system. Run the same command on xvdf2, a second partition I'm making it as a file system. Mount the first partition xvdf1 on, let's say, /data directory. Mount the xvdf2 partition on slash, what is the directory that I created sometime back, app. Now you see df command, guys. You see xvdf1 is of 2 GB size, right, mounted on /data. xvdf2 is of 2 GB size, is mounted on /app. That app. That's how we can create a volume it into multiple partitions and use each partition as like a separate volume to, right, mount it on a separate file system. Now some of the data I can keep it in the slash data, some other data I can keep it in the slash app file system. Now if you closely look at, right, the slash dev slash xvda is also made as a single partition that is mounted on a root file system, guys. Remember, without a file system you cannot keep any data, right? But how come so far I was able to create a files and directories without me worrying about a file system concept? Because because the default volume xvda, whatever you get it when you launch a EC2 server, that default volume is divided it into a single partition called xvda1. That xvda1 partition is actually mounted on a slash, which is the root file system. That means any file or directory that you are creating under the root, all that data is actually storing in the xvda1 partition, which is part of the xvda volume, right? So let's say now I'm creating a file under the root. Now tell me guys, this f1 file is stored in which volume out of all these different volumes that I have? How do you know? The file is under the slash. Slash is the file system. This is mounted on xvda1. That means your f1 file is stored in the xvda1 partition, which is from xvda1 volume. Let's say I'm creating a slash data slash f1. Now tell me, this time this f1 file is stored in where? The f1 file is created in the slash data directory. Slash data directory is a file system which is mounted on xvdf1. So definitely this f1 file is stored in the xvdf1 partition from this xvdf volume. That's how we need to understand the directory to the volume association or mapping, guys, just to see which data storing it in the which volume. So if you are not using any additional volumes, right, obviously any file that you are creating will belongs to the root and the data will go to the root volume only. That I wanted to avoid, right? I wanted to store my business data in a separate volume. That is where I started off mounting my custom additional volumes into a separate file system, and you can start keeping the data in these directory structures. That way the data will not go to the root volume. I'm just dividing my data. Any OS specific data will go to the root volume. Any business specific data will go to the custom additionally created volume. That's how the goal here. Let me clear the screen. So with this, I'm introducing you the EBS volumes from the AWS side and how to get a volume. The volume can be, mounted as it is, or the volume can be divided it into the partitions and use the partition to mount it as a file system that I have shown you. The other thing, let me go to any one of the file system. You see I created a file. What will happen when you create a file? Let's say this is the volume where I'm creating a file. Can I say this statement? When you create a file, the file has to store in the volume somewhere, correct? So it has to understand, right? The file should be, what is the size of the file? The file should be storing in which block in the volume, which block is free, which block is already filled with some data. Agree with me? That kind of the information should be known by a volume, right? Or else how it will start storing the data. So usually when you create a file, right, the file is assigned with a number called inode number. Stat is a command to see the details of a inode assignment of this file. We can see the stat output which states that this file is assigned with a number called 12. The inode number is the unique number that is assigned to the files within the file system. This inode number is used by the system to understand this file is stored in which block and where the data is stored. Out of, let's say, out of 100 GB of volume, my file is stored in which place, in which blocks. That kind of the information should be known by the system, right? That's how it is assigning a unique number called inode number, and this inode number will be having the details of a file name, the file permissions, right, and the file ownership groups, right. All the information will be stored in this inode table just to understand how this file is being created. But this is good, not enough, right? In order to handle, let's say if I'm creating some 100 files, all the 100 files should store in this same volume only, right? In order to manage these things properly, right, when you create a, yeah, when you create a, sorry, there's a mismatch in the slide, guys, give me a second. I'm just giving more details how exactly the file system concept works. When you create a file system in a volume, as you know that the volume is divided it into a number of blocks, right? And definitely each block will have a number, block 1, block 2, block 3, block 50, whatever the number of blocks that it has, it's assigned a number for that blocks, right? So when the volume is divided it into the blocks, sometime back we have seen that the blocks are added as a block groups as well. Let's say each group may have some number of blocks, maybe 100 blocks are belongs to block group 0, another 100 blocks belongs to block group 1. That's how some block groups also will be get divided. Now when you are storing a F1 file, the F1 file should store in which block. Let's say the block size is 4 KB. If your file size is 8 KB, then your file has to be stored in two blocks, right? Because one block is 4 KB, your file is 8 KB. It has to use two blocks to store the data. But which are those? How it know which block is free, which block is used? That's where, right? By default, when you create a file system, it will be maintaining a super block information. Super block is the block which is reserved to store the characteristics of your file system. When I say a characteristics, is mean that, right, the super block is the block in your file system which is containing the details about total how many blocks are there, what is the total file system size, how many total block groups are there, right? That kind of the information will be stored in the super block as a group descriptors. It also maintains the data block bitmap in the sense, right, which block is free, which block is already filled with some data. That kind of the information will be stored within the super block level. It maintains inode bitmap as well. You remember sometime back my file was assigned with a number 12. It should not give that number 12 for any new file that you are creating in the same file system. How it know that the number 12 is used by so and so file? It has to maintain a record, right? The inode bitmap will store the information saying that this number is given to the F1 file. This number is for so and so file. All that bitmap, the assignment will be managing by this inode bitmap table. The inode table will maintain the actual history. 12 number is given to the F1 file. F1 file, who is the owner, who is the group, right? And the permissions, all the details will be stored there. The data blocks, this is where exactly the data stored. But when you are creating a file, when it is storing the file in the file system, first it will go and check the super block just to verify, right, which number is free, which inode number is free, which data blocks are free, right? And it will see how many number of data blocks are free, what is the file size, whether it has enough number of blocks or not to store the data. It will just do all those calculations from the super block level. Once it all good, the file will be stored in any one of the available blocks. Then the super block will be updated with the new file information saying that this file is created with a so and so inode number, so and so data blocks. That's how the super block is maintained. It's like a indexing that you guys can maintain in order to manage the data that you are storing. This is just a backend information how the file system concept works. As you see, the super block is containing the size of the file system, number of inodes nodes, number of data blocks, how many are used, how many are free, that kind of the information. Can I use this statement? Right? The statement is, without a super block, you cannot store any data in the volume, guys, in the file system. Why? The superblock is the main block which is containing the details such as to understand the data should be stored in which blocks. Even when you are trying to read the data, superblock will help you to know your file is stored in which blocks out of these thousands of blocks of your volume, right? So if the super block is corrupted in the sense maybe if it is not maintaining the proper indexing of your file system information, then your file system will be not in a usable manner. Your file system will be corrupted in the sense your super block is not having the right information, you can't get to know. Let's you take some 1,000 pages of book, right? Without a index page, how difficult for you to locate the data and get the data, guys? Got me? Same thing, the data might be there, but because the index is not there, you cannot go to that right location to pick the right data immediately. That's how the things works here as well. So without a super block, your file system is not a usable manner. So sometimes there are chances that your super block will be corrupted in the sense, it has some wrong index value and file system is not in a usable manner, right? So you can use a command called FSCK.ext4 and specify your volume, your file system name. This is the command to verify whether your superblock is good state or a bad state. Ideally, this FSCK file system checking command, FSCK means file system checking the integrity of the file system, whether the file system is good or not, right? This command cannot be run on the mounted state. Why? When the file system is in use, right? When the file system is in use, we can't run the checking, right? You unmount that file system. Now you run the FSCK command there. It will tell you that your file system is currently clean. If the file system superblock is corrupted, it will tell you that the file system is corrupted, right? So I can give the F flag, a force flag, just to give you more information. You see, the file system checking, the FSCK command is actually checking the number of inodes, blocks, sizes, whether the directory structure is good or not, right? All this information is verified just to ensure that your file system is clean. If it is not clean, something is wrong, your superblock is corrupted, your FSK will try to correct the file system by adjusting or fixing the issues as well, guys. So if in case your file system is corrupted, we can fix the file system by using the FSCK command. But for now, I'm showing you the commands, right? How do you check the file system superblock integrity status by running the FSCK command, guys. FSCK dot, if your file system is ext4, then give the ext4. If your file system is ext3, then give ext3. That is how we can make use of this file system, guys. Good. Now let me run df5 punch. One last point that we need to know about it here, right? Usually you are using the mount command to mount a directory on a volume to start using the volume, right? Usually after the system gets rebooted, your volumes will not be mounted automatically. As you know, if the volume is not mounted, obviously, right, you cannot use that volume to store the data or access the data. If you are expecting your volume has to be mounted automatically even after the system reboot, then you need to maintain the information of your file system in a configuration file called /etc/fstab. In this file, you need to add an entry saying that this is the volume name. I want this volume to be mounted on this particular drive. This is ext4 type of the format. Use some default properties to mount this. During the mount process, right, I don't want any file system checking has to be happen. We can make it as 0. I don't want to take any backup of this file system, make it as 0. The last zeros whatever I am using here, which says that, right, whether you are expecting the file system integrity has to be checked or not during the reboot time, whether it has to take the the dump or backup of this, right, for any reason if this is getting corrupted, that kind of the details case. It's always better to make it 0, 0, which is a best practice. So I don't want any integrity check needs to be done during the mount process after the reboot. So this is how we need to add a syntax in the configuration file and save the file. That's it. After the reboot, automatically this volume will be get mounted on this drive. We can start using the volume to store the data. Well, so this is the story, guys. The agenda of this story is all about how will you be adding the additional EBS volumes to the EC2 instances and how to make use of them by creating it as a file system either directly or making it as a partitions, and understanding the Superblock terminology and how to do the Superblock consistency check and the df-h, the file system utilization pattern, and mount unmount commands, guys, right? So this is the story for today. If any questions, do let me know, or else we are good for today lecture, right? So tomorrow we'll talk about the logical volume management. Thank you.